Science feels like a collection of facts you either know or don't. Yet anyone who has tried to explain even the simplest concept knows it rarely lands as intended. Evolution is often imagined as a linear ladder from simple to complex. Gravity is treated as a force that pulls objects down, and quantum mechanics is reduced to mysterious magic. These simplifications are not failures, they are human attempts to make sense of complexity, but they also create widespread misunderstandings. What feels intuitive is rarely complete. Part of the problem is how science is communicated. From classrooms to headlines, information is often condensed into digestible bites. This encourages retention, but also promotes distortion. A single sentence can reshape a concept in ways that stick, while omitting nuance. Contrast this with the messy, iterative reality of scientific discovery. Hypotheses are tested, revised, sometimes discarded entirely. Reality is rarely a straight line from question to answer, but we crave certainty, and our brains prefer tidy stories. Misunderstandings are further amplified by cultural expectations. Humans love narratives, cause and effect stories, and characters who succeed or fail. Science rarely delivers neat plot lines. The universe does not act to satisfy intuition or morality. Yet, stories of progress, design, or inevitability sneak into explanations because they resonate emotionally. Contrast the comfort of these simplified narratives with the factual complexity behind them, and it becomes clear why even intelligent individuals misinterpret concepts repeatedly. Another source of confusion lies in language itself. Scientific terminology is precise, but everyday words are not theory. In science means a rigorously tested explanation, while in casual conversation it suggests speculation or guesswork. Energy, force, and random carry very different meanings in physics than in everyday life. These linguistic gaps create fertile ground for misperception. What is assumed to be familiar is, in fact, often a distorted translation. Finally, human cognition itself contributes to misunderstanding. Our brains rely on heuristics, shortcuts that simplify overwhelming information. These shortcuts work well for survival, but poorly for abstract or counterintuitive concepts. We see patterns where none exist, overgeneralize from limited observations, and default to familiar explanations even when evidence points elsewhere. Contrast the elegance of a correct scientific model with the intuitive but flawed mental model we construct. And you see why misconceptions are not accidental, they are a predictable product of cognition. Understanding why we get science wrong is not about shame or blame. It is the first step toward curiosity. Once we recognize the sources of misunderstanding, simplification, narrative bias, language gaps, and cognitive shortcuts, we can approach knowledge with humility and clarity. By embracing the complexity rather than avoiding it, we prepare ourselves to explore the most misunderstood ideas in science with insight, attention, and a sense of wonder. The universe is vast, ancient, and often counterintuitive, yet our minds instinctively try to shrink it into something familiar. Black holes are imagined as cosmic vacuum cleaners, dark matter is portrayed as a mysterious stuff-filling space, and the Big Bang is pictured as an explosion in empty void rather than the expansion of space itself. These mental shortcuts satisfy curiosity, but they distort reality. Contrast intuition with observation, and the universe appears far stranger and far more fascinating than our imagination predicts. Take black holes as an example. Movies suggest they roam space randomly, consuming planets and stars at will. The reality is more elegant than terrifying. Black holes form from collapsed stars or supermassive centers of galaxies. They follow predictable gravitational laws, affecting only nearby objects in measurable ways. Distance is everything. A black hole hundreds or thousands of light years away is irrelevant to Earth. Contrast the dramatic imagery with the cosmic truth, and you realize that the terror is mostly human projection. Then there is dark matter, the invisible scaffolding of galaxies. Popular descriptions often simplify it into a ghostly substance or even an exotic particle floating through space. In reality, dark matter is inferred from gravitational effects. We cannot see it, but we can measure its influence on the motion of stars and galaxies. Contrast the eerie mystery conveyed in headlines with the subtle, quantitative evidence that defines its presence. It is not magic. It is careful deduction, hidden in plain sight. Our misunderstanding extends to cosmic events as well. The Big Bang is often imagined as a classic explosion from a single point, yet it was an expansion of space itself. Galaxies were not hurled into pre-existing space. Space was stretching, carrying matter along with it. Contrast the intuitive notion of a central explosion with this more accurate view, and the scale and mechanics of the universe become less about dramatic spectacle and more about continuous processes unfolding over billions of years. Even time and distance in the universe defy intuitive perception. Light years, gravitational time dilation, and relativistic effects are all conceptually challenging. People often misinterpret the age of stars, the distances to galaxies, or the behavior of objects near massive bodies. These misunderstandings are not signs of ignorance. They are consequences of brains evolved for survival in a three-dimensional, relatively slow world, not for interpreting relativistic phenomena. Contrast the limits of human intuition with the evidence-driven perspective offered by astronomy, and you see the universe anew. Cosmic misconceptions are also reinforced culturally. Movies, books, and social media favor drama and simplicity. Stars explode violently, planets wobble uncontrollably, and black holes lurk everywhere. This narrative bias strengthens errors, making accurate understanding seem less exciting. Contrast the allure of dramatized cosmology with the patient, often subtle beauty of real processes, and it becomes clear that awe is not diminished by accuracy, it is enhanced when curiosity meets fact. Finally, understanding the universe correctly requires reframing familiar assumptions. Gravity is not a pull from invisible strings, but a curvature of spacetime. Galaxies are not static islands, but dynamic systems shaped by unseen matter. Black holes are not ravenous, but predictable consequences of mass and density. By embracing contrast between expectation and observation, we begin to appreciate the universe as it truly is, a vast, elegant, and sometimes counterintuitive system governed by rules that are consistent yet astonishing. This foundation sets up the next step. If our cosmic intuition is so often misleading, what about the more familiar, biological, and life-based ideas we hold? The next section will explore how humans consistently misinterpret life itself, revealing patterns in thought and perception that extend from the stars down to the microscopic. Life is often presented as straightforward in popular imagination, yet the reality is far more intricate and nuanced. One of the most common misunderstandings is that evolution follows a linear path, progressing from simpler to more advanced organisms. People imagine a ladder, with bacteria at the bottom and humans at the top, as if evolution has a goal. In reality, evolution is a branching, opportunistic process, guided by environmental pressures, mutations, and chance. Contrast the intuitive ladder metaphor with the tangled, complex tree of life, and it becomes clear that the straightforward narrative misleads more than it teaches. Consider natural selection. It is often described as survival of the fittest, which conjures images of competition and dominance. While competition exists, natural selection also rewards adaptability, cooperation, and random chance. Many traits that appear purposeful may have arisen due to indirect selection pressures or historical contingencies. Contrast the simplistic strongest survives interpretation with the nuanced reality. Evolution is context-dependent, multifaceted, and rarely directed toward any particular outcome. Genetics is another area rife with misconceptions. Popular culture frequently implies that genes alone determine destiny, intelligence, personality, or appearance are fixed and inevitable. In truth, genes interact with environment, experience, and stochastic processes, producing variability that is both remarkable and unpredictable. The contrast between deterministic intuition and probabilistic reality highlights how easily misunderstandings embed themselves in culture. Our fascination with simple cause and effect stories often overrides the subtle complexity of molecular biology. Historical examples also illustrate how misunderstanding shapes public perception. In the early 20th century, eugenics misapplied biological ideas, leading to dangerous social policies. People assumed that complex traits could be neatly inherited, ignoring the interplay of environment, culture, and gene expression. Contrast the perceived simplicity with scientific reality, and we see how intuitive but flawed reasoning can propagate not only misunderstandings, but serious consequences when applied outside the lab. Another common error involves the concept of perfect design in organisms. Humans often assume that structures like the eye, the wing, or the immune system are perfectly optimized. While evolution produces remarkable solutions, they are compromises shaped by constraints, historical accidents, and survival pressures. Contrast the appearance of perfection with the messy improvisation of natural history, and we begin to appreciate the elegance in imperfection. Adaptation is rarely optimal. It is sufficient. Microbes also challenge intuition. Bacteria, viruses, and other microorganisms operate at scales and speeds that defy human perception. Many are beneficial, yet they are often assumed to be harmful simply because they are invisible. Disease is dramatic, but microbial life also maintains ecosystems, drives nutrient cycles, and enables survival for countless species. Contrast perception with function. What we fear may be as essential as what we love, revealing the complexity of life beyond superficial appearances. Understanding these misconceptions reshapes our approach to biology. It encourages critical thinking, appreciation for complexity, and humility before the diversity of life. By recognizing the gaps between intuitive narratives and scientific reality, we prepare to see life in a way that honors both evidence and wonder. This sets up the next section, which will examine the mind itself, how cognition, perception, and consciousness are frequently misunderstood, revealing patterns that extend from life's biology to the very ways we interpret reality. Our brains are extraordinary organs, capable of interpreting a flood of sensory data, generating thought and creating an internal model of the world. Yet this model is imperfect. One of the most pervasive misunderstandings is that perception is literal and objective. People assume that what they see, hear, and remember accurately reflects reality. In truth, the brain filters, reconstructs, and even invents elements of experience, producing a version of reality that feels coherent but is often subtly distorted. Contrast this intuitive trust with the science of perception, and the mind reveals itself as both reliable and fallible. Optical illusions are the simplest illustration. A straight stick appears bent in water, parallel lines seem unequal depending on surrounding shapes. Motion is sometimes perceived where none exists. These are not tricks of the eyes, they are evidence that the brain interprets rather than records. Contrast what feels obvious with the underlying processes at work, and it becomes apparent that perception is not a passive reflection, but an active construction. Everyday experience is full of similar, less obvious misinterpretations. Demonstrating the brain's constant negotiation with incomplete data, cognition adds another layer of complexity. People often assume thought and memory are fixed, yet the mind constantly rewrites experiences. Memory is reconstructive. Each recall alters details, influenced by context, expectation, and emotion. Conversations remembered years later may feel vivid and accurate, yet contain subtle errors introduced over countless reconstructions. Contrast the confidence of recollection with its fragility, and it becomes clear that even personal experience is subject to distortion, challenging the assumption that our minds are trustworthy recorders. Biases further shape understanding of reality. Cognitive shortcuts, like confirmation bias or the availability heuristic, simplify decision-making but skew perception. People notice patterns that reinforce existing beliefs while ignoring conflicting evidence. Contrast the subjective certainty these biases create with the objective unpredictability of information, and the discrepancy between perception and reality emerges. Our brains prioritize coherence and efficiency over factual precision, producing a world that feels understandable even when it is not. Consciousness itself is frequently misunderstood. People imagine it as a single, unified observer within the brain, controlling thought and perception. Neuroscience reveals a distributed process. Multiple networks process sensory input, memory, and attention simultaneously. Subjective experience emerges from these interactions, not from a single self in charge. Contrast the intuitive notion of a singular mind with the evidence of distributed processes, and consciousness appears less like a simple actor and more like a symphony of interacting parts, producing coherence where there is underlying complexity. Attention also deceives. Inattentional blindness shows that people often fail to notice unexpected objects when focused elsewhere. Selective focus shapes what we perceive as real, highlighting that even the simplest acts of awareness are constructed rather than automatic. Contrast the seeming completeness of conscious observation with the blind spots and omissions that exist, and the mind's interpretive power and its limits become evident. By understanding these patterns, misconceptions about cognition and perception are clarified. The mind is not unreliable by accident, it is optimized for survival, efficiency, and coherence, not for perfectly accurate recording. Awareness of these mechanisms allows critical thinking, reflection, and a more nuanced engagement with reality. This prepares the stage for the final section, where we will explore how recognizing these patterns enables better understanding, clearer thinking, and a deeper connection to the world around us. Understanding that so much of what we believe about the universe, life, and our own minds is distorted can feel unsettling, but it is also empowering. Misconceptions are not failures, they are opportunities. Recognizing where our assumptions go astray allows us to refine our thinking, approach problems with curiosity, and engage with the world in a more thoughtful and informed way. Contrast the comfort of intuitive beliefs with the clarity gained through reflection, and a new kind of insight emerges. The first step is awareness. By acknowledging the brain's tendency to simplify, overgeneralize, or misremember, we can pause before fully trusting intuition. Everyday decisions, social judgments, and interpretations of data benefit from this mindfulness. Contrast habitual assumptions with deliberate observation, and it becomes possible to identify errors before they shape outcomes. Awareness acts as a lens, revealing the hidden architecture of cognition and highlighting where perception diverges from reality. Critical thinking is the next tool. This involves questioning patterns, testing assumptions, and seeking evidence rather than accepting appearances. Science itself thrives on this approach, constantly refining understanding through experimentation, peer review, and revision. Contrast the intuitive rush to judgment with the disciplined evaluation of data, and it is clear that deliberate inquiry is not slow, it is precise. By cultivating this mindset, misconceptions become manageable, and uncertainty is no longer a source of fear, but a guide to exploration. Observation also transforms under this approach. Misunderstandings in science, from cosmic phenomena to cellular biology, demonstrate the importance of paying attention to detail, contextualizing information, and integrating multiple perspectives. Contrast the superficial impression that a topic is understood with the depth revealed by careful examination. Each layer of insight builds upon the last, reinforcing that complexity is not a barrier, but a path to deeper understanding. Humility plays a central role. Accepting that much of what we intuitively know is flawed encourages openness to new information. It fosters collaboration, curiosity, and patience, while reducing overconfidence in our own interpretations. Contrast the arrogance of assumed knowledge with the freedom of intellectual humility, and the mind becomes not a static repository of facts, but a dynamic tool for inquiry and discovery. Finally, embracing these principles allows curiosity to thrive. Misunderstandings become invitations to explore, question, and learn. They transform fear, confusion, or frustration into fascination. Contrast the allure of false certainty with the excitement of ongoing discovery, and the pursuit of knowledge becomes both a personal journey and a universal one. Recognizing misconceptions is not about eliminating error. It is about channeling it into understanding, reflection, and creative insight. By the end of this journey, the audience is left with a shift in perspective. Knowledge is not a fixed endpoint, but a continuous process. Misunderstanding is not a barrier, but a tool, teaching us about cognition, reality, and the limits of perception. Contrast what we assumed we knew with what we now appreciate, and the universe and our minds appear more intricate, challenging, and profoundly inspiring than ever before. This mindset encourages questioning, learning, and intellectual humility, leaving the viewer ready to engage with science not as a set of static facts, but as a living, evolving dialogue.